gases are then taken into a condenser system. This is petrochemical 101. What we do here, we keep the superheated gases recracking, so they continue the molecular breakdown. This is a thermal cracking process, if you can recognize a petrochemical application. And what happens is that what comes from above condenser 1 into condenser 2 is a much lower temperature, lighter product. So what is recovered here is liquid, medium crude, and light crude. So from that stone, what you're actually taking out is a liquid that is not only light crude, but it's also very clean because it doesn't have any of the sludge or minerals that come from production, from liquefaction of the resource. And also a process that is a product that is upgraded, that it finds its way to any market refinery. Finally, this is where it really gets interesting. The effluent that keeps there, which is a gas effluent, or the remains of the gasification process, basically is a mix of several things. And we've come up with a way to separate very cleanly by maintaining a pressurized chamber with CO2 under pressure, by keeping temperature at below 100% Fahrenheit at all times. What we're effectively doing is maintaining a constant of temperature. And in these little critical orifices here, we're effectively, our ability is to modify the boiling point of the gases, so you can actually separate them cleanly. So here's what happens. What came as a gas is now separated into very clean products. These are pentane, butane, and methane that are coming to a compressor into a holding tank. Then you capture all the CO2, both the one that you put in and the one that is created in the reaction, and it's also separated and contained. This can be used for clean purposes in the market, either for flushing of production wells or for welding and other purposes. This is the methane that Walter was talking earlier. This is also captured here, and this actually can be used as natural gas for combustion or for high-tech industry because of its purity. But finally, and this is the most percentually, the biggest amount of product that comes out is hydrogen. So imagine in a commercial matrix of production wells from our technology, we could have the potential of a hydrogen-based power plant in our facility because of all the hydrogen that will be created. Finally, if you think about this, all these gases now self-contained can be sent back to the heater that produces the heat in the first place for self-heating. So it's a closed system that is energy self-sustainable. So the net result, we don't use third-party energy to produce our energy. Therefore, we produce a clean product that is oil, but it's oil in its purest and cleanest form. And it doesn't have any emission because everything is captured. Now what happens is that, of course, all that product is going to be recovered, it's going to be taken to the market, and finally we're going to have an empty shaft here, an empty vessel. So we take our process out, our pipes out, and we take all the CO2, I don't think ours, but anybody else's CO2 that is around, and just imagine, this is Wyoming, all these, process plants and electricity plants. There's right now a huge pipeline that takes CO2 into Canada to flush production wells over there. But we can take a lot of that CO2 and flush it back into the same place where we took the oil from. And what happens is that because the pores where the oil used to remain in that rock is now a bigger pore, it's much greater. It is also charred. This acts as a really good adsorption mechanism. Adsorption with a D, by the way. It's a chemical, physical property that will bond the molecules of CO2 to the charred pores. We presented this technology to the Department of Energy in April. We are right now in the middle of a due diligence with them in terms of the technology because I believe that this is one of the areas where the current administration has more. Yes, sir.
Yeah, you said GSI is a wholly owned subsidiary.
GSI.
Did I get that right?
That's GSI is right now a clean private entity, and the majority ownership happens to be a public public company,
Which public company?
Earth Search Sciences.
What business are they in?
Hyperspectral imagery. So their business is to find resources.
So they map, they do underground maps?
That's correct. That's correct. And this is an older technology. We can get to that, with all detail. But
Are there other investors besides the public company?
yes, yourself. I mean, your servant is one of them, and friends and family that we brought in to put money into the initiation of the technology.
So it's the public company and then individuals?
That's correct. That's right. So that is the basis of really the technology and how it works. In fact, in short, the environmental friendly components of it is that it's very low risk of water contamination. This is a very critical point for any of the pushbacks that are currently holding development in the oil shale industry in this country. But in our process, there's really no risk for groundwater contamination. Minimal emissions, low water consumption, minimal environmental footprint. Everything you saw there is built on skids. Basically, everything is built on a movable platform. So as soon as the production is done, we just move our equipment to the next lot, the next acre, and everything that was there is just replanted. Nothing happened really. And because we don't have a third-party energy requirement, and we have the ability to carbon sequestrate, our carbon footprint is actually comparable to current conventional oil extraction. This is one thing that and actually you mentioned that in your presentation, you are not accounting for carbon credits, but that is a huge opportunity for us, because once we've completed the production, that is actually carbon sequestration vehicle.
So just to summarize, list for me all the outputs that are coming out of this process.
80%, actually, right here. 80% liquid products. This is oil, light crude, and medium crude is about 80 to 90% of that liquid product, and about 10% of heavy crudes that are used for
All your liquid products meet the specs?
Yes.
For pipeline quality?
These are 25 to 45 API in different API viscosities. And the reason it's different is because it's a cracking process. So as the process goes in time, the tail end of the process is much lighter product, because there's much more residency time underground to take all those products out.
So go through your gas products? Or
Yes. So
you got 4 gas products?
well, there is yes, primarily the C3s to C5s are 17%. Then the methane is about 20%, and then hydrogen is 45%.
What's the BTU quality of that?
3,500 no, 2,800.
Method,
2,200. Thank you, Hector. Look.